Good morning and welcome to our science class. I will be your science teacher, Mrs. Adeline C. Mejia. Our lesson for today is about Newton's second law of motion, which is also called the law of acceleration. Our objectives for this session is that at the end of the period, the student should be able to show the effect of force and mass on acceleration. Next would be to state the law of acceleration. And the third one is to solve word problems involving the law of acceleration. But before we proceed with our new topic, let us have a review of the Newton's first law of motion. Now you will choose whether the given statement is true or false. For the first one, inertia is a property of a body or an object to resist the change in its state of motion. Is it a true or is it a false? Let's check if your answer true is correct. Very good, because inertia is the resistance of an object to changes in motion. For the second one, the greater the mass of the object, or the heavier the mass, the greater is its inertia. The harder it is to change its state of motion. You answer false. Let's check if your answer is correct. Sorry, your answer is incorrect because it is true that the greater the mass of an object or the heavier the object is, the greater is its resistance to motion. Therefore, the greater is its inertia. Now, for the third question or the third statement, wearing of seatbelt based from the law of inertia will cause injury or accident to the driver and the passenger. Is it a true or is it a false? Let's check if your answer false is correct. Very good, because wearing of seatbelt will definitely not cause injury to the driver or passenger. It will protect them from bumping their heads on the windshield in front. So now moving on to our lesson for today's session, let's have activity number 1. You have to guess the mystery word given the image on your screen. What is the mystery word for this image? K. You answered mass. Let's check if it's correct. Very good. Mass is the amount of matter that makes up an object, and it is measured in kilograms. Next one. What is the mystery word with the image having a push and a pull? Very good. It is a force. Now, a force is any influence that, when unopposed, will change the motion of an object. A force can cause an object with mass to change its velocity. For example, to accelerate. Next one. Guess the mystery word for this image. A moving car. So what is it? Very good. It's acceleration. Acceleration can either be an increase or decrease in the speed of the object or change in direction, which is expressed in meter per second squared. Now, let's define first what is a net force. When a body is acted upon by forces and the sum is zero, meaning there are balanced forces, it will either stay at rest if it is at rest or will continue moving with constant speed along a straight line when original in motion. Net force is equal to zero. Now, let's see the image on your screen with the two elephants pulling a log on opposite direction. The force of the elephant on the left is 200 Newton. The force of the elephant on the right is 200 Newton. Since they have both equal forces, the net force is zero. Okay. When forces on the body do not equal to zero, the net force results in motion. Now we have here two persons on opposite direction. Okay. On the left side, they are giving 500 newtons of force. On the right side, they are giving 450 newtons of force. So they have unequal forces. One has a greater force and the other one has a lesser force. So which do you think will the rope move? Or in what direction will the rope move? Will it move to the left or will it move to the right? Very good. It will move to the left since they are giving 500 newtons, which is greater than the 450 newtons on the right side. Next, let's see the relationship between the force and acceleration. On this image, the kid is giving a small amount of force on the ball, which will lead to a small acceleration or which will produce a small acceleration. The other image below, which is giving a large force to kick the ball, wherein it will produce a large acceleration. Okay. So what do we mean by this? If a body is acted upon by forces that result in unbalance or net force, the body will either increase or decrease the body's speed. The rate of change in speed, the acceleration is directly proportional to the increase or decrease in the force applied. So what do we mean by this? Based on the image a while ago, if we give a force that is small or lesser, it will produce a lesser amount of acceleration. If we provide or give a force that is greater, it will produce a greater acceleration. Now, let's see the relationship between mass and acceleration. On the left side, the image on the left side, a lady pushing an empty cart. On the right side, a lady pushing a cart full of groceries. Okay. So which do you think among the cart will produce greater acceleration given the same amount of force? Is it the empty cart or the cart full of groceries? Which do you think? Very good. The empty cart will produce greater acceleration. Okay, let's see. How is that so? Acceleration is inversely proportional to the mass of the body. When you push a grocery cart filled with canned goods, it will accelerate less than when you push an empty grocery cart with the same amount of force. Given the same amount of force, the empty grocery cart will accelerate more because the grocery cart, which is full of canned goods, is more heavier. Therefore, it will produce lesser acceleration. Now, let's define Newton's second law of motion, which is the law of acceleration, given the relationship between force, mass, and acceleration. It states that the acceleration of a body is directly proportional to the force applied on the body and is inversely proportional to its mass. The direction of the acceleration is in the same direction as the net force. Now, given this equation, it can be written simply as force is equals to mass times acceleration. Force is expressed in Newton or kilogram meter per second squared. The mass is expressed in kilogram, while acceleration is expressed in meter per second squared. Given this formula triangle, we can derive the different formulas for F is equals to ma. Now, if we are looking for the mass and the given variables are force and acceleration, what we're going to do is that force divided by acceleration is equals to mass. Now, if you are looking for acceleration, force divided by mass is equals to acceleration. Okay, now we have here sample problems. For number one, a car which has a mass of 2,000 kilogram accelerates from rest at a rate of 2 meter per second squared. How much force was applied on the car to attain this motion? So you have the given variables, which is the mass, which is equal to 2,000 kilogram, and the acceleration that is 2 meter per second squared. Now we are looking for the force. So here is our sample problem with the sample computation. Given mass 2,000 kilogram, acceleration 2 meter per second squared, and the force which is unknown. Now force is equals to mass times acceleration. We substitute the given mass is equals to 2,000 kilogram multiplied by 2 meter per second squared. So which is equal to 4,000 kilogram meter per second squared or 4,000 Newton. Now the force applied to the car to attain the 2 meter per second squared is 4,000 Newton. Did you get it? Now here is another sample problem. Suppose a ball with a mass of 0.5 kilogram is hit with a force of 12 Newton. What will be its acceleration? So the given variables is mass, which is 0.5 kilogram, a force of 12 Newton, and we are looking for the acceleration. So given mass is equals to 0.5 kilogram, force 12 Newton, and acceleration is unknown. So we have the formula force divided by mass. Now 12 kilogram meter per second squared, we use the kilogram meter per second squared instead na Newton so that I can show you how to cancel the units. Okay, now 12 divided by 0.5 kilogram is equals to 2.4. Now we will cancel out the kilogram so that the meter per second squared will remain. Now therefore, our acceleration is 2.4 meter per second squared. Okay, for you to be able to practice solving problems relevant or related to the law of acceleration, you will answer the following problems with your group mates and present your work tomorrow. So you are divided into 4 groups. For group 1 problems, an object with a mass of 5 kilogram accelerates 7 meter per second squared when an unknown force is applied to it. What is the amount of the force? So you are looking for the force. Number 2, you are pushing a friend on a sled. You push with a force of 20 Newton. Your friend and the sled together have a mass of 60 kilogram. Ignoring the friction, what is the acceleration of your friend on the sled? Here, you are looking for the acceleration. Now, for group 2 problems, a student pedaling a bicycle applies a net force of 400 Newton. The mass of the rider and the bicycle is 25 kilogram. What is the acceleration of the bicycle and the rider? So you are looking for the acceleration. Number 2, an object with a mass of 1,500 grams accelerates 10 meter per second squared when an unknown force is applied to it. What is the amount of force? Now you are looking for the amount of force. Now you check on this one. The given mass is 1,500 grams. But our unit for the mass is kilogram. So you have to convert the 1,500 grams into kilogram before you proceed with the computation. Now for group 3, how much force will a tennis racket need to exert on a tennis ball with a mass of 0.65 kilogram to make it accelerate at a rate of 5,500 meter per second squared? Now you are looking for the force. Number 2, an object with a mass of 15 kilogram accelerates 2.5 meter per second squared when an unknown force is applied to it. What is the amount of force? So you will look again for the force. Number 4, group 4, how many newtons of force are needed to accelerate a 100 kilogram at 4 meter per second squared? Number 2, an object accelerates at 6 meter per second squared with a force of 70 or with a mass of 72 kilogram. What is the amount of force? Okay, you are looking for the force. Okay, are there any questions? Now, if you don't have any questions, let's call it a day and you can message me for any further questions or clarifications. Thank you for attending and participating in our class.